You have a cosine function. I want to make it into a sine function. Over to you, everybody. Take a couple of minutes and get that done. Anyway, let's get to this, right? Anybody want to volunteer their answer? Right? Anybody thinks they know what that equation is? I'll take it from anybody, right? So Noah says he can. Okay, Noah, go for it. So it's a sine function that we're looking for now that would mimic or be the same as this cosine function. Go for it, please. Tell me what you got. So I started you off. It's y equals sine pi over 2x plus or minus something. Let's hear what you got. Okay, so we're just going to give Noah a chance to type in his answer. We'll test it out. And if anybody's unsure of why his answer works, we'll find out if it works in a minute. Then, so he says x plus a half. Okay, so x plus, oh, that's not a plus. Plus fraction over 2, 1 over 2. Okay, so the way this works, Noah, is when I ask the smartboard to draw this function, those lines should be in the same place. They should overlap, right? So let's see what happens when we do this. Oh, look at that. They do, right? The orange line just wrote over the whatever the color of the other one was before that. So they're clearly identical. Hopefully everybody is clear on what Noah did to get his answer and we can move on, right? Can you show how you got that? Okay. So Rachel, not just Rachel, we know we need to add, according to what this says, add a quarter of the period. What was the period of this function again? Can you remind me what the period of the function is? Did you figure, first of all, you have to figure out the period. Did you figure out what the period of the function was, Rachel? 4, perfect. Let's divide that by 4, which gives us what? 1, okay. Let's add 1. So look at the graph that you have, or the equation you have. It says x minus a half. So it's minus a half plus 1. Do you see that? And minus a half plus 1 would be plus a half. Wouldn't you agree? Just leave out the pi part. The pi part. I'm not leaving it out at all. It's pi over 2. It's right there, Jeremy. Right? So it's a half. So do you see what we got plus a half from now, Rachel? Does that make sense to you now? Right? Okay. Jeremy, what do you mean by leave out the pi part? The pi is there. It's pi over 2. It's right there. What do you need? Okay. All right. So there you go. There's your equation. And the two equations match up very nicely. Now, we're going to have to do something else here. We're not given a graph. In fact, now we have to actually graph for ourselves. It says create a cosine function with the following transformations. The amplitude is 2, the period is 6, the phase shift of 0.5 to the left, and a vertical translation of 3 up. Then we have to write an equivalent sine function, and then we have to draw our own graph. Hello. All right, that's not something we've done before, but doesn't mean we can't do it. So let's think this through. Let's think this through. They gave us the amplitude. They gave us the period. Gave us the phase shift. They gave us the vertical translation. So all of that's there. Can we come up with an equation that matches all of that? Let me fold over my laptop so we can start doing that. Just give me 1 second to get this going. Okay, ready to go, folks. Ready to go. So what does this look like? Let me remind you what it says. Amplitude of 2, period of 6, phase shift of 0.5 to the left, vertical translation of 3 up. That's not that difficult at all. We have the A, we have the D, 0.5 to the left, we have the C of 3 up. So I'm assuming everybody understands that this equation is going to look like the one I'm about to write now. So y equals 2 cosine. Okay, here's the part I'm not sure about. I need some help with this. All right, I'm kind of stuck here. The period is 6. What does that translate to in terms of a k value? Can anybody help me out with that? Right? We usually have the graph, we can look at it and find the period, and then we find the k, and absolutely. What we do is 2 pi divided by the period to get the k. So 2 pi divided, in other words, 2 pi divided by 6, reduce that down, pi over 3. So pi over 3, and then we have that shift to the right of x, but it says to the left, I think it said. Let's double check that. Yeah, 0.5 to the left. So I wonder if I should change that, because that's on this grid here, it's going to be a little difficult to put 0.5 to the left. How about if I change this? What if I change this to maybe something like 4? Let's make it 4 to the left, right? Just to make it easier on this grid right here. Putting in a half is going to be a little challenging. So let's say x plus 4, because we're going to the left. And then the vertical translation, we said was 3 up. So plus 3. Now, okay, Keontae is now checking in. Let me take care of that. Okay, thank you, Keontae. It's important that as soon as people join, if they know that they joined late, that they let me know that they're late. Okay, that they're here, rather. All right. I wonder if, now that we've written our graph, written our equation, rather, right? The challenge, of course, is to putting this on a graph eventually, but now that we've written our equation, can anybody tell me where you think the high of this equation would be? What would be the max of this equation? And also, what would be the min of this equation? Is there a way that we can look at the equation and get the max and the min? Can anybody suggest what the max might be and what the min might be? How high does this go? What's my max? That's max on the y-axis, that is. And how low does this go? Does the equation help us to get that information? Right? Can anybody suggest how I could do that? Because you have enough information from what we did yesterday to figure that out, right? Does anybody know how high this goes on the y-axis and how low this goes on the y-axis? Anybody? Anybody out there? Hello? Hello out there. Hello, grade 12s. Anybody home? I'm knocking on the door right now. Nobody there? High point, low point. Nobody? How about if I give you a clue? Where's the center line? Right? Where's the center line of this function? Y equals what is the center line? Y equals 3. Thank you. That's the center. The amplitude, remember, tells you how far you are from the center line going up and how far you are from the center line going down. Does that kind of give you a clue here? Okay, so Jeremy is now saying the high would be 5, and he's right. How about the low? Remember, focus on that center line. The amplitude is the distance from the center line to the top and the center line to the bottom. So the min would be low, would be 1. Sorry. Well done. In fact, for me to draw this, what I'm going to do is I'm going to put that center line in first for me to draw this, right? That's my starting point. So we'll get to the sine function later on. We'll do that later on. Let's just see if we can start putting this graph together right now. So I'm going to go ahead and I'm going to put in my center line, right? This is practice that hopefully if you have graph paper close by or a digital version of a graph paper that you're trying for yourself. I'm going to put my center line in right now. So here comes my center line. I put it in red. Center lines and asymptotes and that kind of thing are always dotted. We'll remind you about that. So here comes my center line right about here. Okay. Now, let's think this through some more. A cosine function starts at its high point, right? If I take you back to the very first page of when we started looking at this, that's not the first page here. A cosine function starts off at its high point on the y-axis, high point of 1 on the y-axis. This particular graph that we're doing, if I could get to it, this particular graph that we're doing does have a starting point, but it's not on the y-axis because it's been shifted to the left by 4. But we know where the high is. The high is at 5. So why don't I put that first point on the graph, 5 to the left, not 5, sorry, not 5. It's been shifted, 4, sorry. 4 to the left and all the way up to 5. So I'm going to put that on right now. I'm going to put everything on in red, by the way. 4 to the left and up to 5, right about here. I'm going to say that that should be the first point on my graph, right? I'm showing you what's called the 5-point strategy for sketching a graph, sketching a cosine or sine graph. If you're drawing a cosine graph, start off with its high point based on what you know the high point to be, and also how far that high point is from the y-axis, right? We know it's been shifted to the left by 4. That's what this says. Well, it didn't say that at first. I changed it to 4. 4 to the left. So that's why my high point is here, 4 to the left, up at 5. Here's the next thing I'm going to do. I said it's a 5-point strategy. My next point is going to be at the end of the cycle, right? How long is this cycle? How long is this period again? We used the word before. It's 6. So a whole cycle should take me back to my starting point. So it means that if I am up at 5, by the time I get to the end of the cycle, I should be back up to 5 again. Now, I started off at -4, and the cycle, as Noah just said, or the period, is a 6-unit period. Where should that cycle end then? 6 units away from -4 should take us to what? Should take us to 2. So let's put that right there. Now, we could also go the other way, right, and say 6 units away from this should be at -10. And that's certainly one way that we could write another cycle, or draw another cycle, rather. Excuse me. So -16. -16. Yeah, you're right. Another one at -16. You're right about that. Fair enough. So I put in 1 6 away to the left of -4, which takes us to -10. And we could also put another 1 6 away from that at -16. Yeah, that's reasonable. Okay, so we have 4 high points now. The low point we said, let me go back and show you again. You said it was at 1. Okay, good. That is going to occur in the middle of the cycle. Now, how long did we say the cycle was again? The cycle is how long? The period is how long again? Remind me. We just asked a question a few minutes ago, and I think it was Noah who answered it. It was 6. So halfway through that cycle, I should be at 3. So I'm going to go 3 into the cycle. So 1, 2, 3. I'm going to put my low point right there, right? My low point we said was at 1, right there. Okay? And I can do the same thing between these two low points. So between these 2 points, I'm going to say 1, 2, 3. My low point should be right about here. I'll do the same thing over here. We can do as many cycles as we want. That's not, yeah, that is 1. We can do as many cycles as we want, right? 1, 2, 3, right about here. All right, no, I said 5 points. We've got 3 so far. In between, let's just focus on the very first cycle here. In between the first point and the middle point, I should be right on the center line. So in between this point here and this point, which is 3 away, I need to be right in the center. 1 second, please. Throat is very dry. So that would sound like, since the cycle is 6 units long and 3 is in the middle, that would sound like it should be approximately 1.5. So 1, 2, 3, 1.5 between here and here. So I'm going to put my middle point somewhere around here. And the same thing would go on the other side. I'm going to put my middle, sorry, my middle between the low point and the high point right on the center line somewhere around here. And I can keep doing that everywhere along the center line. Everywhere that there is a midpoint between the low and the high, I'm going to put that right on the center line. Right, so right on the center line there, on the center line there, on the center line there. I'm now ready. So the first 5 points give me a pretty good idea of where the next cycle would be. I'm ready to draw this, folks. Don't expect art. I keep warning you. And right after I warn you, you get the evidence of the fact that I don't write or draw very well. But here we go. Here comes my cosine function. All right, it's already off to a bad start. All right, let's back it up. Let me go from this side here. Okay, not bad, not great. Not great, but not bad. Okay. All right. Okay. So I missed a few points. Actually, you know what? It's not that great. No, I'm gonna say no. That's not good enough. Let me try this again. All right, let me try to get my hand in position here. All right, maybe a little bit better. Maybe I caught those points a little bit better. Anyway, there's my cosine function, and I could keep going in either direction. Right? So I've just done the last part of that by coming with 5 points. So here's how the 5 point strategy works again. Know where your high is, know where your low is, right? My high we said was at 5, my low is at 1. How do I know that? Use a vertical translation, add on the amplitude. Even if the amplitude is negative, doesn't matter. If this had been -2, I would still say 3 plus 2. Then I would take that same center line and minus the amplitude. Again, even if it's negative, doesn't matter. So that gives me 5 and 1. If this had been -2, it would still be 5 and 1 because the amplitude is never negative. The A can be negative, but the amplitude is never negative. Amplitude is a distance. So 3 plus 2 gives me the 5, that's the max. 3 minus 2 gives me 1, which is the min. So I know where the curve is bouncing between 5 and 1. Let's just confirm a couple of things now. What we said about this graph. Amplitude of 2 absolutely has an amplitude of 2. From the high to the low, from 5 to 1, that distance is 4. 4 divided by 2 is 2. Amplitude is 2. Is the period 6? Well, from this high to this high, you can confirm for yourself from -10 to -4, that distance is 6. That's absolutely true. Has it been shifted 4 to the left? Right? Well, here's where the cosine function is supposed to start, right at the top here. That has been shifted to left, 1, 2, 3, 4 to the left. That also works. And there's a vertical translation of 3 up. So it's not sitting on the x-axis. That center has been shifted up 3 places. So it is perfectly, and I was able to come up with 5 points initially, and then just kept repeating that pattern over and over and over to get the other cycles of the function. Okay, you need to be able to do that. I'm going to show you another way to do it using transformations, but you need to be able to do that as well. So the only thing that we haven't done yet is to write an equivalent sine function. So that's where you come in. You've had some practice at this by now. We just did this a while ago, just like 2 minutes ago. Well, maybe 5 minutes ago. Take this cosine function, figure out the period of the function, right? According to what we just did, and I'll take you back again. If you want to take a cosine, make it into a sine, add a quarter period. So figure out the period again. In fact, the question gives you the period, divide it by 4, add it onto the current phase shift. The current phase shift is x plus 4, add it onto that. Okay, I'll give you another. I don't need to give you 2 minutes this time. I'll give you a minute to do that because you've done this enough now for you to know what that equation needs to be. I should have to call on anybody in the class now for that equation. So I'm giving you a minute starting. It's now 10:43. I'm going to be asking one of you at 10:44 for what that equation looks like as a sine equation. Go. And there should be nobody sitting staring at the computer now. You should be working on this for yourself. Let me go get my wheel in the meantime. My favorite computer website is that little spinny wheel. Where is my wheel? Here we go. Is that my class? I don't think this is your class. No, that's not your class. Let me get your class. Hold on, is that you? Alex, no, that's not you. Tap to spin. It's spinning while we speak. And we've had the minute. And Archana is the lucky winner. It says it right there on the screen. We have a winner. And the name I see there is Archana. So Archana, you seem like you're actually figured it out this time, Jeremy says. Okay. All right, that's good. So Archana, check in for me, please. First of all, let me know that you're there. Where is Archana? Perfect. Okay, Archana, can you tell me what your equation looks like as a sine equation? I'll give you a few minutes to type, 2 seconds to type it into the chat. I'm assuming you have it ready to go, so please type it into the chat. And we'll see if everybody agrees with you on that, by the way. I'm going to start you off. I know some parts of it that you should have. Y equals 2 sine. I'm assuming you're going to say pi over 3. Then you're going to tell me what goes inside the bracket. Then we're going to have plus 3 on the end. Okay, so 11 over 2. So x plus 11 over 2, approximately 5.5, same thing. All right, so what do all the people think? Let's take a quick vote on that. Are we on board with Archana? Did Archana get this right, or is she just making up stuff? Emily and Karis and Jeremy and Joel and Kristen and whoa, okay. Everybody jumping on the Archana train, but she's right. Okay, so 11 over 2 means same thing as 5.5. It's really 4 plus 1.5 or 3 over 2, right? So absolutely makes sense. All right, good stuff. Good stuff. Noah gives it a thumbs up there. All right. Well, I said I was going to show you another way to do this, so I'm going to do that right now. This question says, graph one cycle of each of the following. F of x equals 2 sine, and it gives you all the features of the function. And there's a second one, which is a cosine function. We'll do them both. That might probably take us up to the break. I have about half an hour left, and this might take a little while, but it's not that hard. The fact that I'm saying it's going to take a while, it doesn't mean that it's difficult. It's just that it takes a while to do it. So here's how I'm going to do it this time. I'm not going to sort of try to put the high point, the low point, and all that good stuff. We're going to do it a different way. We're going to have a table of values, and we're going to use transformation logic this time, transformation approach this time. So I'm going to put my x and my y. Actually, let's use black. I'm going to put my x and my y for a sine function, and I'm going to call the second column x prime and y prime, meaning what happens after you transform it. Okay? So by x and y, I mean my radian measures for x and y. Let me see if this table is big enough, though. Hang on 1 second. This is a table, right? Or is it just a picture? It is a table. Yeah, my admin is a little bit bigger. Give me a second here, folks. Where did this come from? All right, I'm just going to use what I have. So what I'm putting into the table are the same 5 points that would be on a starting, is this sine or cosine? Hang on, sorry, sine function. And that would be 0. That would be, I don't think I like how this table is behaving. Hold on. Let's try it again. That would be 0. That would be pi over 2. That would be pi. That would be 3 pi over 2. And that would be 2 pi. That would complete the horizontal axis for one full cycle of a sine or cosine function. It doesn't really matter. Now, let's get to the y values. When the angle is 0, help me out, please. What y value, go back, if you think back to what we started off doing yesterday, what y value should I put for when, we're talking sine, right? This is for sine. Right? What y value should I put when x is 0? Right? What's the corresponding y value? Come on, folks, we've done this. We know this. Right? In other words, what's the sign of 0? That's what I'm asking. Okay, good. 0. Perfect. When it's pi over 2, what is it for that? Thank you, Kayla. Thank you, Jeremy. Thank you, Karis. And thank you, Archana. How about when it's pi over 2? When x is pi over 2, it's, thank you, Emily, and Kayla, and Archana, and Jeremy. Really appreciate all of that, and Elizabeth. Really appreciate all that input. We put the rest of them in. It's going to go back to 0. It's going to go to -1. Then it's going to go to 0. Right? So everybody hopefully has a gist of this. These are the typical x and y values on a sine function before it's been transformed. So no transformations have taken place on this function. Okay? Now, I want you to think of this just like transformations, where the A represents what we used to call the vertical stretch, and the C is what we used to call the vertical translation. So what we normally do, if you remember, is we would take each of our y, remember, those things affect the y values. Hopefully I'm not talking something that sounds Greek to you, because we did this, right? This is something that we did probably unit 1, I think. I don't remember when it was, but anyway. But we did this, where we said that we took the 2 and multiplied it by each of the y values, and then we added on whatever the vertical translation was. So we take the vertical translation and multiply it by the y, and then we add on whatever the vertical translation is. Vertical, what did I just say? Vertical stretch, sorry. We multiply by the vertical stretch, and then we add on the vertical translation. So in the first case, I'm not talking about the x's, we'll get to the x's. For this y, I would take 0 times the 2, which is still 0, plus 3. So that would be 3. I'm going to keep doing the same thing. 2 times the 1, which is 2, plus 3, which is 5. I'm going to get the same thing for 0 again I got before, which is 3. Right? It's the same 0 like before, so it's not going to give me a different answer. It's 0 times the 2 plus the 3, okay? But when we get to -1, it's going to be 2 times the -1, which is -2, plus 3, which of course is 1. Okay? And then the last one is going to be 3 again. Right? Because every time we had 0, it was 3. It's not going to give you a different result because it's the same 0, the same y value of 0. Let's go with that again. Every single y value got multiplied by 2, and then we added on the vertical translation. So 2 times 0 would be 0, plus 3 is 3. 2 times 1 would be 1, plus 3 is 5. Then we got the same thing for 0. 2 times -1 is -2, plus 3, which gives us 1. And then the same thing for 0 at the end here. Okay, so I'm hoping everybody is comfortable with our y values. For our x values, things are a little strange. So here's how we have to do our x values now. Hopefully you remember this from the stuff we did with transformations. We divide by this, and then we either add or subtract this. In this case, we're going to be adding because it says x minus pi. So I know that's kind of weird, but that's how it is. So we're going to take the value of the x, we're going to divide it by this, and we're going to add on, so we're dividing by 0.5, by the way. We're dividing by 0.5, and then we're going to add on the pi. So in the first example, it would be 0 divided by 0.5, which is still 0. And we're going to add on the pi. So the first answer is going to be pi. Okay, let me say that again. Just want to make sure everybody's following me. We divide, we underline it, we divide by this value. So the k value, we're going to divide by the k value. And we either add or subtract the number that's in the bracket. In this case, because it says minus, we're going to add it. So we're going to add pi to each answer. Okay? Second one, we're going to take the pi over 2. Sorry, remember, we're focusing on the x values now. The pi over 2, we're going to divide that by 0.5. Remember, dividing by 0.5 is equivalent, in case you didn't know this, let me write this down. I'm dividing by 1 over 2. That's the same thing as multiplying by 2 over 1. Just saying, okay? If you're dividing by a half, it means multiplying by 2. That's just a fact. So, the 2's will cancel, and we're left with pi. Then I'm going to add that pi that we have on the end there. So it's actually going to be 2 pi. Everybody got that? Do we do that because k is a factor, right? Remember, Jeremy, that we did this with transformations a while back. We're not varying from how we did this with transformations. We've always divided by whatever the horizontal compression or stretch was. Remember that back then? Like for the parabola. Yes, exactly. Exactly, just like the parabola. Right? We always divided by whatever the horizontal, whatever that number in the front of the bracket was. We always divided by that number. So that's exactly what we're going to be doing here as well. It's no different with this. So think of it just like a transformation. All right. So we're going to use 2 pi for that. The next one is going to be pi. So let me erase this. Right. And let's put in, what's this x value? That's pi. I'm going to divide that by 1 over 2 again, or multiply it by 2 over 1. That makes sense. And then we're going to say that's going to be 2 pi plus another pi, which gives us 3 pi. Now, what you'll always notice when you're doing this is that there's a pattern here, a very obvious pattern, as a matter of fact, when it comes to the x values. Since the x values go up by a set amount, right? Let me just point that out to you. If you look at your x values over here, you're going up by half a pi. These values over here are going to go up by a set amount as well. So it started off at pi, when it went to 2 pi, went to 3 pi. Well, I think you can kind of figure out what the next one is going to be. Come on, folks, it can't be that hard. It was 1 pi, then 2 pi, then 3 pi. So where do you think this is going? No kidding. No kidding. And we can confirm that still, 4 pi and then 5 pi. Now, if you're not sure, if you still are not convinced, try this one. So it's 3 pi over 2, right? Multiplied by 2 over 1. We did say that. You dividing by a half, which is what the k value is, means dividing by a half is multiplying by 2 over 1. So that's going to give me, the 2's are going to cancel out. I'm going to have to 3 pi plus pi is 4 pi, so that's why that's right. Okay? So I now have my table of values and I'm ready to draw my graph. So I didn't have this scale in terms of anything because I wasn't too sure what the scale needed to be. Now I know the scale needs to be in terms of pi. So why don't I do this? Why don't I say that I need to go as far as how many? 5 pi's. So let's say that I'm going to make this, obviously this would be 0. Let's make this, each of these would be 1 pi. So this would be 1. No, actually, let me stretch it out some more. Let's stretch this out some more. Let's make it, hopefully I have enough room for that. 1, 2, 3, 4, 5, 6, 7. All right, I'm just gonna arbitrarily go that 1, 2, 3. I'm gonna make this 1. I think I have enough room if I do that. 1, 2, 3, 4. Make this 2. These are all in terms of pi. I put the pi on later on. 1, 2, 3, 4. This is 3. 1, 2, 3, 4. This is 4. Yeah, I have enough room. 1, 2, 3, 4. This is 5 pi. So each of these is pi. All right. And let me just sort of make my points a little easier to me to spot. I'll mark them off in green right there. 1, 2, 3, 4 right there. 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 And there. Okay, so here we go. We said that at pi you were at 3. So I put that in red. 3 is somewhere around here. At 2 pi was at 5. That's about here. At 3 pi was back at 3. At 4 pi I was at 1. And at 5 pi I was back up at 3. This is my sketch of the function. And I could continue that indefinitely in each direction. But that's just one cycle of the function, right? And how did I draw that? I didn't sort of try to see, okay, where's my center line? And okay, from the center line, I'm going to go, where's my high, where's my low? I didn't do that at all, right? Pi to the left, or pi to the right in this case. But you can see it was pi to the right. You can see that you did shift pi to the right here, which is what this is saying to do. And that the cycle from 1 pi over to 5 pi is 4 pi, which is what this 0.5 would suggest would be the period of the function, right? If I did 2 pi divided by that, I would get 4 pi. So this does have a period of 4 pi, okay? So there you go, folks. Using transformations, you can actually draw your graph as well, right? Okay, we're going to try this now on another graph. We're going to use the table again, right? But this time we're going to do the second one, which is the cosine function. This one right here, right? And hopefully you'll see some differences. Again, we could try to draw this by using the first method, right? Which is to get that, put the high point, put the low point, put the end of the cycle, all that. But we're going to use the table. We're going to use the table again. So this is for a cosine function this time. So look at what the differences are going to be when I start doing this. It's still x and y. Go back to black. Still x and y. And I'm still going to use the same x values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. That didn't change. My y values need to change because I'm now drawing a cosine function. So let me see, I know you're good, but let me just sort of push you a little bit on this. What should be the value for 0 on a cosine function? Let me remind you, it's a cosine function. So when x is 0, what is y? It's, thank you very, oh, look at that. Can always depend on this class. Look at that. Sharissa, Emily, Archana, Noah, Liz, all of them came in with the correct answer of 1. Well, I put the rest of them in. This is going to be 0. It's going to go to -1. It's going to go back to 0. Then it's going to go back to 1. Right? You can double check that for yourself. But those are the values that you should have for each of those angles. So 0 is 1. Pi over 2 is 0. Pi is -1. 3 pi over 2 is back to 0. And 2 pi takes you up to 1. All right, we're going to go through the exact same process. So this says that the a value is -3. I'm going to multiply each of my y values by -3. And then from that, I'm going to -1 from that. Let me say that again. Take each a value, multiply it by -3. And then I'm going to -1 from that because that's what my vertical translation says. This is what my a value says to do. So focusing on the y's now, not the x's. We'll get to the x's later. The y's are usually a little easier. So I'm going to multiply by -3. So 1 times -3 is -3. -3 minus 1 is -4. Oh, by the way, let's call this x prime and y prime. So that's the result. This is the images of the points. So -3 minus 1, of course, is -4. Is anybody not clear on how I got that value? Because I can go over that again. All right? Please let me know if there's anyone who's not sure about that -4. I don't mind. And it's not that because you want me to explain that you're not, you're somehow behind the rest of the class. I had to ask a lot of questions when I was a kid, and you can too. Okay, so let me continue. 0, well, if I'm going to multiply 0 times -3 is still 0, and then -1. And then -1 now. So it's -3 times -1, which is +3. And then I'm going to -1 from that, which would be 2. And then 0 is going to give me the same result as before. And 1 is going to give me the same result as before, which is -4. Okay? I want you to notice something. I said to you before, you want to get the high and the low, you take the value at the end that I'm pointing to right now, right? The vertical translation, and then you add on the amplitude, add it on. Doesn't matter whether it's negative or positive. I said that. I'm going to repeat it. So I took the -1, or I should take the -1 and add on 3. That should give me my high point. -1 plus 3. Forget that it's negative because on top of the amplitude is the distance from the center to the top. -1 plus 3 is 2. That's why our high point here is 2. -1 minus 3. Not -3. Just -1 minus 3. -1 minus 3 is -4. That's why that's your low point right there. Okay? So our low point is -4. Our high point is 2 based on this information that we have. Okay, let's now go over to the x coordinates. And again, you should see a pattern. And once you see the pattern, it makes your life a lot easier. But let's see if we can get the first one first. Here's our k value of 0.25 pi. So what I'm going to do is I'm going to take my x value and divide it by this. Then I'm going to subtract the 2. Remember, always do the opposite. I'm going to subtract the 2. Well, it turns out that 0 divided by anything is still 0. So 0 divided by this is still going to be 0. Then I'm going to minus 2, which gives me minus 2. Okay? Pi over 2 is next. So I'm going to take the pi over 2. I'm going to divide it by what's really a quarter pi. So let's call it pi over 4. Right? 0.25, just think about it. 0.25 pi is a quarter pi, or the way I say it is pi over 4. And then I can do this. I can multiply by the reciprocal of that, which is 4 over pi, right? And then, of course, the pi's will cancel out. I'm left with 4 over 2, which is 2. And then, according to what this thing says, I'm going to subtract 2, right? Because this says plus 2, I'm going to subtract that 2, so it's going to be 0. Okay, we can't see a pattern yet because we've only done the first 2 numbers. And we have to make sure that we do at least 3 for us to see the pattern. The next one is pi. So I'm going to erase this. I'm going to put in the pi, which I'm dividing by the pi over 4 again. Right? So pi is my x value, I'm dividing by pi over 4, which means multiplying by 4 over pi, same thing again. The pi's are going to cancel, and I'm going to be left with 4, and I'm going to be minusing 2 from that, which would, of course, give me 2. I think the pattern should be fairly clear at this point. What do you think my next number is going to be, folks? Look at how the x values are trending. From minus 2 to 0 to 2. What's next? What's my next x value after that? Okay, Richard, look at that. Look at that. So proud of this class. Of course it's 4. You're going up by 2's. So it means that you really don't have to do a ton of work to get this table once you've established a pattern for the x's. The y's, the y's are not that hard either, right? You multiply by the first number, and then you add or subtract the last number, and you're off to the races. So it means that I can now number my scale, not in terms of pi this time, but in terms of regular numbers, 1, 2, 3, 4, 5. And let's see now. So I'm going to go with, I need to go as far as 6. So, okay, so maybe I'll just say 1, 2, 3, 4. Just put a little dot beside each of these ones here. Maybe I should have made it this close together. And this should be 5. And this should be 6. Yeah, I probably should have spaced this out some more. Yeah, now that I think about it, yeah, I'm going to change this. I'm going to change this. All right, so let's see. Let's do the same. Let's use the same scale as before because we have lots of space here. So 1, 2, 3, 4. That's 1. 1, 2, 3, 4. That's 2. 1, 2, 3, 4. That would be 3. 1, 2, 3, 4. That's 4. 1, 2, 3, 4. 5. And 1, 2, 3, just enough. That's 6 on my x-axis. Okay. I also need to go to the negative on this. So let's go on this side. 1, 2, 3, 4. That's minus 1. 1, 2, 3, 4. That's minus 2. Here we go, folks. Minus 2 takes, I'll put this in red. Minus 2 takes us down to minus 4. 0 takes us to minus 1. 2 takes us to 2. 4 takes us to minus 1. And 6 takes us to minus 4. So here is my cosine function. All right, kind of messed up at the end there. Let me see if I can fix this a little bit. 6 down to minus 4. All right, there is your function right there, right? Again, using transformations, right? I'll remind you what the process is. We put in our typical cosine values, right? So cosine values would be, well, the x values are the same for cosine or sine. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Nothing different between that and sine. Then for cosine, we start up at our high point of 1, as you all said. We go to 0, then we go down to minus 1, and we go back to 0, and we go back up to 1. This is a quick recap. Do you always need just 5 ordered pairs to get a full pair? You do, Noah, right? You absolutely do, right? So remember, you start off with a full cycle. If you go from 0 to 2 pi, Noah, that is a full cycle, right? So that means that since you start off with these 5 points of a full cycle, you're going to get 5 points of a full cycle as well. It may be a longer cycle. In fact, this cycle is longer because it goes from minus 2 to 6. This is actually a period of 8, right? That's how far apart these points are. The period of this function is actually 8. But it is a full period still, okay? The high point and the low point rule out applies to cosine functions. Only applies to cosine functions. Okay, I'm not sure what you mean. The height, no, it does not. No, that's not true. No, that rule applies to both. In fact, let's go back, Harish. I'm glad you asked that. Let's go back and look at the one we had before, right? This is my vertical translation of minus 1. No, sorry, the first one was this one. My vertical translation of 3, and here is my vertical stretch of 2. So my high point should theoretically be at 5, which is what this is right there. My low point should be 3 minus 2, which is 1, which is exactly what this graph does. If we look at the second function, which is a cosine function, we'll see the same thing. Minus 1 plus 3, remember you're adding on, doesn't matter. It doesn't matter whether it's a minus 3 or plus 3, so amplitude, so we're just adding it on. So minus 1 plus 3 is 2, which is what the high point is here. Minus 1 minus 3 is minus 4, which is what the low point is here. So that little hack that we just gave you, which allows you to figure out from the equation where the high and the low are, works for both sine and cosine. Okay, Harish, does that make sense? I just want to make sure that you're okay with that. Okay, and Noah, you were asking whether it gives you a full period, and I'm answering to that. I'm saying yes, the x's are in pi or not for the cosine graph. Doesn't matter if this, let me tell you how you know whether the final values are going to be in terms of pi or not. If the k value, excuse me, if the k value is in terms of pi, then it means that you're not going to have pi in your scale. Your scale is going to be a 1, 2, 3, 4, 5 kind of scale, likely. Right? You'll notice that these two tend to go together. You have no pi here, and then you have, sorry, you have a pi here. Let me say the other way around. You have pi here, then you have no pi here. Over on this side, you have no pi here, and you have a pi here. This is when you're going to have a pi scale. This is one when you're going to have a no pi scale. Because putting the pi in the k cancels out the pi, is what we're saying. Okay? And that's what this leads us to. And I believe that is it for this class. Hopefully I've answered your question, by the way, Noah and Harish. Okay, I hope I have.